The SD Ruby podcast is brought to you by New Relic.
Hey, good evening. So my talk is actually the opposite of Scott's talk. It doesn't mean this one is better than the other. It's two different approaches to the same problem. So this is about concurrency and web servers. So Node.js is a web server, but it's also a lot of other things. I'm not going to spend too much time talking about Node because we're talking about Puma tonight. And Puma, to understand why we're talking about Puma and to understand why the web server matters when you use a web server, we need to talk about the web stack. So let's talk about the usual Ruby web stack. At the top you have a browser, usually, or you might have an API client, depending on who the users are, but usually you have a browser, and the browser will make a request, and usually you have a web server proxy like Apache or Nginx. And then behind that, you have a Ruby web server. So I'd like to know what you guys use. Who's using FCGI? Okay, who used FCGI back in the days? Okay, a few people, good. I'm glad nobody uses that anymore. What do we have? We have Rainbows. Anybody using Rainbows? No? Rainbows is Unicorn, but for slower requests. Who's using Unicorn? Anybody? A few Unicorn users. Thin? Anybody? Good. Mongrel? Nobody? There's Mongrel 2 now, but that's a different story. Passenger? Anybody? Okay, a few people. Am I missing anything? Besides Puma? Heroku uses usually, well, with Heroku you can choose which one you use. By default it used to be thin, but now you can pick, I didn't put WebKit. Anybody using WebRick in prod? Yeah! Good job, Patrick. In one line it's a bit faster, but I would recommend you consider something else. Okay, so you have this web server that will talk to your Ruby code. And to talk to the Ruby code, there's rack in the middle. Rack didn't exist a few years ago, but now I think all the frameworks besides Merb, I think that's not fully rack compatible yet. Well, it is rack compatible, but it's not built on top of rack. Everybody uses rack, and rack is the adapter between the web server and your code and your application, which could be a Rails app, Sinatra app, just rack app, anything else. So now that we have this stack, the question is, how do we get concurrency? And by concurrency, I mean how do we handle multiple requests at once? Because if we have one process, and this process can handle one request, the concurrency is limited to one. So in the case of a few of these servers, or web servers, everything is process-based. So Passenger, the way it works is it will start a first process, and this process will then be forked, and based on the load, it will fork even more processes, and these processes will be fed by Nginx or Apache to handle the request. So the web server, the proxy on top, will handle all the load, and will load balance to the different processes. If you use a copy and write friendly Ruby interpreter like RE, when you create a fork of your Ruby process, the memory is being shared, and you don't double the memory, so there's an advantage there. But you still need to start more processes, and each process will handle a separate request. So you can handle one request per process, and you can have multiple processes running at the same time. Now there is one thing you can do at this point is to actually start using threads. So within this process, you could handle multiple requests by having multiple threads. But it gets really tricky. And in the case of some web servers, you can't do that. Unicorn, for instance, the approach of Unicorn is different. It's that it's forking also the process like Passenger, but in a different way and not going through a C++ layer that Passenger added. And the concept is each request gets a fork. And this way the fork gets removed. Actually, that might not be true. They might reuse the forks. But the concept is you have one process per request, and that's how it works. Same thing for Mongrel. So in Mongrel, what you would do back in the day was to start the amount of mongrels you wanted to get a certain amount of concurrency. So if you wanted to handle, let's say, 5 requests per second, 5 concurrent requests, and that's not 5 requests per second, you would start 5 mongrels. And you basically get a request that will be handled at the same time, and you will be maxed out to these 5. With things like unicorn and passenger, this amount can be scaled based on what's available and the configuration you have. So if your system can handle more because the CPU is available, more forks will be created. Now thin is a bit different because thin uses event-driven. It's based on event machine, and it's the same concept as Node.js. And it uses a reactor pattern that accepts a lot of concurrent requests, and then will handle the different requests one by one and send the responses. It's great for very short-lived responses, so very short response time, and especially non-blocking requests. So this way, when you're doing an I/O, the web server can handle an I/O block, the web server can handle another request and send it if it's faster. So if you do a lot of really short response time, around 30 milliseconds, thin is really great. The problem is you need to start multiple thins. So if you want to handle, if you have multiple cores, because Ruby or MRI doesn't support running threads across multiple cores at the same time, you need to start multiple processes. And usually you would start the same amount of processes as you have cores. So if you have 4 cores, you will start 4 processes, and usually that should max them out. Now the advantages of such an approach is that it's really easy to scale. You just add more processes, more machines, and it's easy. There's not much code you need to add. You still need to be careful what you write, but if you need more load, just add more processes. You need more concurrency, add more servers. Now the problem is that there's a cost to that. It costs you a lot of CPU and a lot of memory because you need to duplicate all these things. So it's easy, but it comes at a cost. And that's where Puma came to exist. So Puma was written by Evan Phoenix, who wrote Ruby News. He's also my boss, so I'm not going to say anything bad about his awesome product. But later on you can come and talk to me, I'll tell you. So Evan wrote Ruby News, which is an implementation of Ruby in mainly Ruby. I think it's 90–95% Ruby. So he knows Ruby a little bit, and he figured, well, in my world, and it's in Ruby News too, we don't have a global lock, which means that threads can handle, can run in parallel on the same core and multiple cores. So because we have these threads that share the same memory but run at the same time, why is there not a Ruby web server that can handle, let's say, 16 requests concurrently using threads? Because that would work fine with JRuby, with MacRuby, with Ruby News. We should do that. And actually, with Ruby 1.9, it would work great. But I'm getting ahead of myself. So Ruby News is purely written in Ruby, besides one C extension, which is the HTTP parser that comes from Mongrel. So the HTTP parser is still written in C, so it can be really fast. But everything else is in Ruby. So you can go to the GitHub repo, you can actually see the code, and it's fun to actually see how it works and what's done, and that it might not be that complicated at the start. It's designed for modern Ruby, so that's what I was explaining. JRuby, Ruby News would work great because they don't have global locks, so they have real threads that can run concurrently. Ruby 1.9 has real threads, but there's still a global lock, which means that on one CPU, so with one process, you cannot have requests being handled by 2 different threads exactly at the same time. Now, the thing is, when within your request you make an I/O request, like let's say going to the database, the lock is being released, so the other thread can work. So if you have a Rails app and your request takes 150 milliseconds, and out of these 100 milliseconds, you have 100 milliseconds spent in a database or in Redis or something else, this time can be used by other threads to handle the CPU part. So even using Puma on Ruby 1.9, will be faster than using, let's say, one process of something else. And we'll see that actually it's faster than using multiple processes. But it would work better with Rubinius and JRuby. The concept, as I explained, is that we have one process, and this process will handle concurrency by doing parallelism if available, otherwise just concurrency. The difference between concurrency and parallelism is that concurrency can be achieved different ways, but parallelism is done only one way, which is you have exactly within one process a lot of response done exactly at the same time. It's also meant to be really easy. It's meant for a beginner in Ruby that just comes, install the server. It should be that simple. Installing it should be just gem install, and that works fine. It's also meant to be memory friendly. I don't know if you have this issue, but usually Rails apps are kind of big in memory. We load a lot of things in memory, they get bloated, and we end up being limited by the memory we have on the server. You end up reaching the memory you have on your VPS, and you say, well, I need a new server. And you need a new server not because you're running out of CPU, but just because you're running out of memory. And Puma is trying to solve this issue by not wasting that much memory. So to start with Puma, you just need to type gem install Puma, whatever the Ruby you have. If you have Ruby 1.9, don't use Puma, that's a bad idea. And if you use Ruby 1.8.7, I meant, you should not be using 1.8.7, so try to upgrade to 1.9. To start the server, you just type Puma and it works. So if you're inside a Rack app or a Rails app or a Sinatra app, you say Puma. If you have a Ruby file that's a Rack app, you can say Puma and then the file and it works. Something I really like with Puma, especially in local development, so you can use Puma locally for development or in production. And what I like is when I run locally, I can run HTTP and HTTPS. I don't know if you have this issue, but I really don't like to have to run Nginx, set up the certs, get all the stuff ready, to be able to run my application with HTTPS. So something I really enjoy is to just do that. Now that looks nasty, but it's actually not that bad. I think there's a bug in the letters version, that's why it's a bit longer. But here I say, start the server and bind port 8080 in TCP, and the SSL port 8443, which matches the 8080. And I pass the key and the certificate for my SSL. By doing that, my server is up and running on port 80 with HTTPS, and I can just run it locally without any issues. You might wonder, how did I get this key and this cert? Well, I figured you would ask me, or you would look at the slides, so I just put the comments for you to have later on. So I'm not going to go through them, but basically that's how you generate a self-signed certificate, and then you're good to go. Something else that's nice with Puma as a small web server is that you can have this, what they call Puma Control. So you can start on top of the normal server on a specific port, a mini rack app that just gives you a few comments. And here I started on port 1445, and I give you the token of secret. Now this token is required to make calls to this control panel. And this is not actually a control panel, it's just an endpoint. And you can send a few comments. You can say stats, and that will tell you how many requests are being processed, how many are being blocked, the type of information the web server will have. You can stop the server like that. You can halt it, which will pause it. And you can restart it. No, halt, I think it's when it's stuck. And you can just restart it. And I will talk about restarts a bit later on. Actually, no, right now. Deployment restart, awesome! So deploying Puma is really easy because there's no crazy dependencies. You don't need to build Nginx, you don't need to do any of that. You just put in your bundle file, and if you use format, you just say, in your proc file, you say Puma and whatever, bundle exec, Puma, and start on the port you want to use. You'll probably still use Nginx, or you might want to use Nginx depending on what you do. Now, the problem with deployment is always the same, is how do I restart when I deploy my code? I change code, and I want to redeploy it, and I don't want to lose connections. I don't want people that are making connections to my site to be disconnected. So if you use something like Thin, and somebody's in the middle of a request and you're killing the process and you're resetting it, they will not get a response, they'll get an error. So what you need to do at this point is to work with a load balancer and kind of start new processes, send them there, send the request to these processes, and then kill the other one. It's kind of a pain. It's doable, it's not that hard, but it's not easy. In the case of Unicorn and Passenger, they have what they call hot restart. And the hot restart is basically it's waiting and killing the processes that are, well, it's not killing. It's waiting for the responses that are being processed, and whenever the process is done, the new one is being started and it replaces them like that. So you end up with new code and nobody being disconnected. That's a very good user experience, especially if you have a lot of load. People will not notice when you deploy code. There's no downtime. When you have a big application like we have at Editing Social, when you have a lot of applications like we do, we don't want people to see the maintenance page for 30 seconds while Rails is rebooting. So we need to have this type of hot restart. Now you can do that two ways. You can use the Puma controller or Puma Control that I just showed you, or you can send a signal and it will restart automatically during the hot restart. There's one thing you need to know though. If within the restart there's a bug in your code or something like that and it crashes, Puma won't try to restart it again. So you need to make sure you use something like Monit or something else to handle this scenario. Now configuration, it's really, really easy. And that's what I like. It's just everything is in the command line and it uses URI parse. So you write an HTTP, what I'm saying, you write a query and it will parse it and take the configuration. So for binding, I showed you that earlier. You say bind to this port and you can bind to a socket, you can bind to a TCP port or an SSL port. For the threads, you can specify the minimum amount of threads and the maximum amount of threads. And when Puma starts, it will start the minimum amount of threads, and as requests come in, it will add more threads in the thread pool until you reach the maximum amount of threads. And I think that when threads are not being used, they're being killed, but I'm not entirely sure about that. So let's talk a little bit about threads. So threads are interesting. They have pros and cons. Threads will allow us to get all the features we talked about. So memory is shared, so we don't waste memory. We can get more from a CPU perspective. In the case of Rubinius and JRuby, they run on different cores, so you can really get a lot of throughput. But you need to make sure your code is thread safe. And what that means is that you don't have shared states between threads. So let's take an example. Let's say you have a class variable, and that's not even thread related, but it's MRI related. Let's say you have a class variable, so you have the double at, and then you have value. Now, if in one request you change its value, the next request coming at the same time in a different thread will actually see this value too, and if one is changing it, it will be changed for the other one too. So you need to make sure that whatever you do within your code doesn't share state in between requests. So each request needs to be well isolated. The good news is for web servers, usually we don't share states. I mean, when you handle a request, you take the request, you process it, and everything is contained within the request, and you should not be changing global states around. Now that's in theory. In practice, that happens that some code might be written and might be poorly written, or just you didn't think about that or didn't see the problem, and you share states and you will see problems and they're really hard to debug. So you have pros and cons. What's important is that in Rails, by default, Rails is not thread safe. And well, I should not say it's not thread safe. It is thread safe. It is, by default, it doesn't allow to have multiple threads running in one process. So unless you tell the configuration, hey, go ahead, don't put a lock, one Rails process can only process one request at the same time. So the concurrency of a Rails app by default is 1, which obviously is not that great. So you might want to remove this feature if you want to use a server multi-threaded server. If you don't use a multi-threaded server, it doesn't really matter much. Aaron Patterson from the Rails team actually wrote a very good blog post explaining why he would like to remove or to change the default to be to use threads if available by default. But that's not going to go in Rails 4, from what I heard. So that's kind of an introduction of Puma, and that shows you the highlights. So apparently Node.js does what, 4,000 requests by second? Is that what you said?
Yeah.
4,000? You sure?
90% sure.
So this is what Puma gives you, 16,000 requests per second. So now these are benchmarks. Don't trust benchmarks. It's easy to cheat. I haven't actually checked on these numbers. That's what Puma advocates. I asked Evan to give me more details, and I wanted to run them, but he told me he has to redo the benchmark. So I would say you can look at this benchmark and say Puma should be at least as fast as Unicorn and Rainbows and other web servers. It could be faster. That's what they say. I was not able to prove it. I didn't really spend time trying to do that. In theory, you should get the same speed or better speed, especially depending on the Ruby you use. But something that's very important is that your memory usage will go down, and that's easy to prove. And I mean, it's very simple. Depending on the Ruby you have, every time you fork, or every time you start a process, you double the memory. In this case, we just have one process sharing the same memory, so obviously we'll use much less memory to get the same amount of throughput. But who's doing 17,000 requests per second here? Anybody doing 4,000 requests per second? I doubt anybody's doing more than 100 requests per second. Anybody? No. So I think whatever web server you use, you'll be fine. What I like with Puma though is that it's easy to run locally. It's easy to deploy. The code base is simple, and it allows me to play with threads, which might or might not be a good idea, but I like it. So, one more thing. So this is kind of it's not really, it's a new feature that was not mentioned anywhere, but I wanted to let you know about it because that's kind of cool. Have you seen the video from Aaron Patterson when he shows in Rails 4 how you can do the streaming? Yes, he showed a video where in Rails 4 what they allow you to do is to keep the connection open for the client. So the client opens the page and connects to you, and you send back a response. And then the server, based on the timer or whatever, will push, update, and stream data back to the client and change in real time the browser using an HTML5 feature. Well, this is done, in the example it uses Puma, and what you do in Puma is you can actually take the socket. So the request comes into the socket, and Puma gives that to your rack handle, and the rack app can say, hey Puma, I'm good, I'll just keep the socket, go back, just tell the client, don't even tell the client anything, I'll just keep the socket. And once you have the socket, you can use something like Event Machine, or you can do your own code, and you can start pushing data down the socket. So you can use WebSocket, you can do whatever you want, by just having the raw level socket. And that's a kind of nice thing that Puma allows because it's very simple code base, and you can do this type of hack. And you can just have fun by creating this web server and keep the socket and write to it and stream to it. So that's it. That was Puma in just a few minutes. This is my Twitter handle if you have any questions. I'll put the slides on the website. Patrick usually have them, so. Any questions? Yes.
If you use the streaming and you hit the maximum amount of concurrent connections to the maximum amount of threads that you set,
yes.
What happens?
So they get queued. Everything gets queued.
Okay, so then one person will wait until.
Correct. So it's load balancing. You have that with all web servers. I mean, even in Nginx, you have a very simple round-robin load balancing. So when all the processes are busy, they'll get backed up, and depending on the proxy you use or the load balancer you use, the algorithm to write to each of them will be different. It's the same thing in Puma. They will all come, they will get backed up, and whichever thread is free will get the request, and they just pop it from the queue.
In your benchmarks, you showed...
They're not my benchmarks, I just want to...
In the benchmarks, you showed it twice. One
Yeah,
was
okay.
KA, was the KA.
Was when you keep alive. So if you use a keep alive connection or when you don't use a keep alive connection. There was also showing with different amount of threads. Because it's not because you add more threads that your server will be faster. It depends on the system, on what the system has available as resources. So it's a bit more complicated than that. So running these benchmarks are always hard because what do? Do you run unicorns with 15 child workers, or do you? So it's really hard to evaluate. But if you boost it as much as you can, apparently you can get up to 17,000 requests per second. Yes.
Do you know of any large daily deal type sites using this in production?
That's a good question. We should ask Groupon. I'm not in a position to answer this question, but what I can tell you is that Engineer uses it, and they offer that to their customers. But I can't answer any questions regarding living social technical stack. Yes?
Do you know if you can use this in Heroku?
Yes, you can, absolutely. You can use it, but you need to use a new stack, which I think is default now, but CDR. Yes?
The benchmarks were using Rubinius or JRuby.
I asked a question and that was not answered.
So
I was going to run all the benchmarks and then it was going to take me too long, so...
do you have any idea how much it gets knocked down if you're still using MRI? Like how much benefit is there to using...
Well, it's a bit hard to say because Rubinius is slower than 1.9 for a lot of things. So it depends on your code, right? Because you'll get the parallelism, but if you do a lot of I/O, then 1.9 is not really an issue because the global lock won't be your problem. For JRuby, it's yet a different issue. I don't know if anybody is using Puma with JRuby. I know it works well, but most people I know use other solutions, so I don't know. But for 1.9, it's a very easy, simple server. What's nice is it's basically you get the advantages of Passenger when it comes to deployment and stuff like that, but you don't have to set up everything for Passenger. So if you use Heroku, it's really easy to just deploy and use Puma for it. And I would say just start by trying that and see what kind of throughput you get. And I mean, I don't know a lot of people that have throughput issues. I mean, even though that's something I like, and I like to try to push a throughput, but besides big companies and video games company, I don't know a lot of people really limited to the point where that becomes such an issue they need to change the stack.
Well, I guess what you end up doing though is needing more servers as opposed to one beefy server that can...
Yeah, that's true. That's true. For me, in my use case, let's pretend it's not real life, right? But if I were to use something like Puma, I would probably use it for APIs. Because APIs are very well, you basically see your code is very simple and you can handle multiple threads, you need good throughput. And usually I would use Thin for that. But the problem with Thin is the hard restart, that's kind of a pain. So what I usually do when I use Thin is I use HA proxy in front of it. And HA proxy does a health check. And we basically send a signal and we say, okay, I'm going to kill this guy, start new processes, switch, and you do kind of a rolling restart without dropping people. But that's not as easy as doing it with Puma. So that's a big advantage. Any other questions?
It's probably worth noting that most Rails apps are I/O bound.
Yes, most Rails apps. I would say probably
You spend
all of
most
them.
your time screwing around in the database,
Yes.
and a lot less time actually
Well,
writing Ruby code.
So there's one exception, is a lot of people have a tendency to have very complex templates, and they might spend a lot of CPU time in that. But I would still say that you're right
still
by
probably
90%. You might have 5% yet. Yes.
Actually, isn't that about to change? I mean,
What is going to change?
Isn't that about to change? The company I'm working for, we're looking at the possibility of putting our databases on SSD.
Oh, you're talking about Amazon? Amazon and SSD? Or just any type of databases? Yeah, but it's more complicated than that. I mean, a lot of database calls you make, they actually go to memory. They don't go to disk, depending on the size of how you handle the data. There's a price of talking through the network and have this I/O call and then something coming back to you. A lot of people also do web API calls. That's also as a cost. So I don't think you will ever get to the point that you get free I/O. But at the same time, if you think about it, when you go in IO land, well, you can handle other requests. So it's not that bad. Alright, yes?
So one of the things that I'd set up for a few of my projects would be memcache or some other sort of caching system.
Right.
So typically we would actually just have Nginx tied directly into memcache. So Rails is writing into memcache, and then Nginx is actually checking memcache serving before even bothering with Rails.
So you're talking about HTTP caching, right?
Yeah, so Rails would generate whatever the request was, and then just write the HTML or XML, JSON, whatever, just as a memcache document.
Right.
So how would caching time with Puma? Would you still require an Nginx or something to pull from memcache, or could Puma actually serve that as well before offering to wrap?
No, in the case of HTTP caching, I would actually not go the Nginx memcache route. I would probably use something like Varnish or Squid instead, which will be in front. It will be a proxy in front of your web servers, and whatever you do, you're gonna have multiple. Unless you have just handle 16 concurrent requests, more than likely you have multiple servers.
Mm-hmm.
So you need to have a way of serving all these servers, and you put the HTTP cache at that level. And the way HTTP cache works is you have a request coming in, it's the server returns a response with an E tag or an expiration tag, and then the caching layer will take this information, and next request coming in will verify if the caches are fresh or not. So it's not really changing much for you. In your specific case, you just use Puma behind Nginx because the Nginx serves you cache.
Mm-hmm. Okay.
All right, beer time.